Good morning, everyone. So, as introduced, I'm Emily Scoones, and I'm a Principal Computational Design Engineer at Ramboll. I actually started my career as a structural engineer, and then over the course of the past sort of 4 or 5 years, I've got into this sort of coding world and started to look at how we can use tech in order to create better solutions for our clients and the industry in all. So today I'm going to be talking about generative design and how we've been applying it, particularly in practice. And I thought I'd start off by discussing what my kind of definition is for generative design. And the eagle-eyed of you will realise that I was not actually, and if you look in your brochure, you'll realise that I was not actually scheduled to do this talk. And actually it was my colleague Paul Jeffries, who unfortunately can't make it today. But I thought I'd make sure that he was still here in spirit by taking a little quote from his generative design blog that he did for us recently. And his description of generative design is the practice of applying algorithms which are able to partially or completely generate possible design configurations on behalf of a human designer. Now, to me, what that means is that we are able to put in constraints, develop the rule sets that create a certain shape or a geometry or a building, as you'll get to see. And what we can do is allow the computer to come up with ideas or configurations that we maybe wouldn't necessarily have come up with ourselves, or a range of solutions that aren't necessarily static, i.e. not 2 + 2 = 4, but actually something that we maybe didn't anticipate. And this is not a new trend. I mean, if you go back to Anthony Gaudi, who used his hanging chain models back in the 1800s and the early 1900s to help to define structural forms, such as the Sagrada Familia, it's something that has been around for a while. And it's been used throughout the architecture industry, things such as the Great Roof at the British Museum, and various of these sort of very complex geometry pieces that you've seen. However, at Ramboll, we've been looking a little bit about how we can take the benefits of generative design and apply it on a much more sort of traditional scale in a traditional work process. And some of these benefits that we see is obviously by using computers, we're able to design and develop solutions much faster and also then evaluate and iterate on that. But the key is not here that we do it faster. The benefits start to build on that by being able to design faster and iterate faster, we're able to explore more of the solution space than we traditionally used to be able to. And by being able to do that, you are able to find better solutions, start to help balance the different constraints, which in the AEC industry are often quite a few, and hopefully, ultimately, make more informed decisions. And for those of you who saw Greg's talk earlier in the morning session, that was something that was really important to us at Ramboll. We are often the structural engineers that come in on a project and say, actually, that's not going to work, or this needs tweaking, this needs changing. And we actually wanted to see how much information we could bring early on in the design process in order to help clients to get more comfort in the decisions that they're making and hopefully avoid those late, costly changes. And that included sort of commoditizing and creating algorithms of some of our own sort of knowledge base. And we've been on a bit of a journey with this. A lot of it started by looking at sort of massing options at a very early stage and evaluating them and seeing how we could optimize them in order to kind of come up with better solutions or at least possible options for our clients. We found quite often that we've tended to be able to be optimizing for height of buildings, for example, in this option, where for this site, there was multiple different views that the client wanted their buildings to be able to see. And as you may know, views are often inherently linked to the value of the apartment, so you can put an uplift based off the views that you have. And so they wanted to undertake a study which, because of the 4 different views, how could they optimize the heights of the different buildings in order to achieve the optimal amount of facade that could see at least one of those views? And so we were able to run, using generative design, multiple different scenarios, giving weightings to various different views to see, what options could be possible, what changes in height could be happen in order to give a difference in that, in the cost and the value of said sites. And we've been doing sort of little projects like this, but actually we've now more recently been developing a much bigger tool called SiteSolve. And this is a generative design tool for early design feasibility for residential massing options, with the idea that you can use the software to import information about your site. You can set in the various constraints, such as height limits, roads that you might want to do, your target mixes that you're trying to achieve, all the sort of information about your building, what are your first floor heights, all of these kind of things, what kind of topology would you like, you name it. And what it is doing is it's then generating possible massing options and optimizing to try and come up with the best or a good solution to meet the criteria that you're trying to optimize for. And what's worth noting at this point is that each of those designs, every time it's generating an option, it's got engineering insight embedded within it. So it's placing the cores based off fire safety rules. It's sizing them based off early stage MEP, vertical transportation requirements. And so at every point, you have confidence that what you're generating should be buildable. And what it allows the user to do is to then, create various different options, understand different strategies that could be followed, and see the outputs for the key sort of area data that at a very early feasibility stage you might be looking for. So your GEA, your GIA, the number of apartments you're achieving. And we also have the ability to evaluate those on other criteria rather than just cost and value. So things such as overshadowing, what kind of spaces are you making, which of these apartments get certain views. And that's something that's sort of hugely important to us because we want to leverage the power and the speed that you can use computational power to help drive better decision making at an early stage. And so being able to quickly evaluate on a whole range of different criteria can help be a part of that. So we've been using this in a few ways. The first is that it's obviously a software that some clients use themselves and some use in a more sort of tech-enabled consultancy style fashion. And what it does is it allows clients to test rapidly various different strategies in order to understand what is the potential impact of following, in the case of what's on screen here, a pure housing development through to apartment, through to some kind of mixed in the middle. And it gives them all those options. And they're able to make a decision from that by being able to see that. We've also been applying it on a bit more of a mass land scale, using the power of computational design to look at portfolios of land for clients. So where they've got lots of pieces of land that they don't know what to do with, they don't know how to prioritize which ones have the most potential, which ones have the best access to amenities, for example. And we recently did this for Transport for London, where we were able to work with a few different partners. Urban Intelligence provided us our sort of planning data, our red line boundaries, our target mixes, etc. We were able to import that information in and obviously use our generative design algorithm to create the massing options. But we also had links in with Turner & Townsend's cost API, so we passed through information, and within a millisecond or so, they were able to send us the cost data for that massing option, and also from Hatchery Generis and HomeTrack, the value data of each of those apartment types that we were creating. And we also looked at various case studies in 30 years' time so that they could test different scenarios. And so we were in the middle, and in each time of this case, we were optimizing for return. But what was really interesting here is that we found from this research is that in some of the sites, because we were optimizing for return, some of these long, thin sites which had various constraints such as difficult topology, they were running right next to a railway, actually it came up that the solution was not necessarily to build as much as possible, but actually to build less so that you still created a positive return, whereas if you had just built everything due to the various constraints, you would have actually come up with a negative one. And to give you a sense of scale of what we did for each of the sites that we were looking at, and it was over 2,000, we ran over 2,000 iterations of options and the various different case studies that we were running, meaning in total that we ran over 10 million options using this generative design platform. And obviously this there was a sort of setup time in sort of developing the methodology and linking up with the various parties, but once it was set up, this took a matter of hours rather than the sort of days, years, maybe months that it would have taken if you were to try to do it manually. And we are able to produce for the client a sort of dashboard which allowed them to kind of prioritize and filter to see which sites had the most potential. Now, one thing that I might note here before I go into my next slide is that we weren't necessarily saying this is going to be your final solution for each of these sites. due to the scale of the number of sites, we were able to work at a level of granularity, which meant, okay, we can identify which ones have potentially the most potential. And this is something that we are very aware of as a kind of maybe a misconception of generative design, that when you run a generative design algorithm, you're going to get the perfect solution. This is definitely most not the case, especially when we get into workflows as complex as the ones we see in the AEC industry, where there's so many parameters that are often conflicting with one another. What's right for one person might be not right for the other person. So be warned when using generative design that doesn't necessarily give you the perfect answer, but what it does allow you to do is to see a series of solutions where you can see the output and the results of these, which would allow you to see the pros and cons of each strategy and help you to make that informed decision. I think one of the ways that I always try to think about it is a little bit through food, which is if you have you have lots of elements of food that you like, but there's various reasons that you eat it, whether it's healthy or because it's very tasty or it's sweet. But for example, if you put lettuce and chocolate together, it doesn't necessarily make a nice thing if you try and mix them to make the perfect solution. And you might be lucky, you might find the new snail porridge and be the next Heston Blumenthal, but more likely than not, and particularly when you have more of these constraints and considerations, you're not going to find something that meets every criteria perfectly. So that's something to bear in mind when looking at sort of generative design algorithms. And one of the biggest things that we find in the industry is that often you're optimizing to try and minimize material usage, for example. And that might mean that you produce a solution that has 274 different panel types. But as you know, the contractor who then has to build that, or the prefab consultant, will probably not be very happy with you having to work out how to put that all together. And so another different solution is still to try and optimize that as much as possible, but also consider the different considerations such as buildability. Similarly, with SiteSolve, we've been running different experiments with different massing options that we create, and we can develop different fitness functions for the optimization criteria that we're trying to optimize for. And we can tweak that to try and see what the different impact is of those on the potential solution. So on the left, you can see we can just maximize the number of units. In the middle, also try to maximize the number of south views, but obviously in architecture that also has the inherent issue of maximizing north-facing apartments. And so if you then start to try and minimize your north-facing apartments, but still try and maximize it, you can see how the algorithm starts to try and angle the blocks in order to make it so it's not a pure north-facing, or create L blocks, which means that it minimizes the number that are facing the north. And what we've really found here is that really generative design is a tool to really help to augment the possible solutions that a human designer can create. And we are very pro that this tool is not necessarily there just to replace architects or developers or whoever might think that their job might be taken from this tool, but actually to augment the process that they're going through, help them to define their strategy and make better decisions by being able to test more and see the different possibilities. And we've done this with a whole different series of tools. So this is a little app that was created once at Ramboll, which was just of a little bridge, as you can see here. And what it allowed the user to do was to kind of push and pull with the ends of said bridge. And it allowed them to be able to see where was the best place for them to put it, but also very instantly see the impact on the kind of structural implications for the bridge and the element sizing. We've also used it, and this is a very early version of SiteSolve, you might see that it's very different from what I was showing you earlier, that we often are able to create lots of different solutions, and our architects are able to kind of take some of the ideas and say, oh, we didn't think about this being here or didn't think about that being here, and take the elements of the design and then evolve it more, taking it forward from what the tool created initially, but using it kind of as a basis. And initially this was a very sort of workflow, not connected process. But from our learnings from this, we've been starting to develop tools that within the software itself, which allow you to kind of lock various different parts of the design in order to say, I like this part, but actually let the computer generate other parts of it, or to push and pull and edit and tweak the massing that is generated in order to find a balance between what the computer is generating and what the human wants to implement. And I think this is really important in our industry because not only do we have the sort of quantitative results, but also there's a lot of qualitative factors that need to be included in our design process. So the title of this presentation included the next generation. And what I just wanted to say here is that I think that the next generation are the computer humans. You no longer need to be a superhuman to spend hours and hours working out all the possible solutions as an architect or a developer or an engineer. We can now use computers to help us and augment that process. And a whole new generation of computer humans is starting to come up. The generations that we're seeing are more computer literate, able to use some of these technologies in a way that really helps to benefit not only their businesses, but also their clients and ultimately the people that are going to be living and using the architecture that we create in the construction industry. So with that, I say thank you, and I look forward to hopefully answering some of your questions or speaking to some of you in some of the breaks later on.
So with that being said, any questions from the audience for Emily? Sure. I'll let you know. Would you actually repeat the question?
For the computation, I'm interested to know whether you use CPUs or GPUs, and is it multi-threaded to cut down the solve times?
Yeah, good question. So obviously we do use a mix of CPU and GPU depending, because obviously the graphics of what we're using is built in a games engine, so it's using some of that. We do also multi-thread, especially now that we've started to build in various parts of the evaluation functionality, which means that some of it is relatively heavy when you're starting to look at ray tracing, etc. So yes, a whole mix of all of those.
Questions?
I'm going to repeat the question so the live stream
The
can get it.
decision basis, you give lots of options for people to look against. What do you think? Oh, sorry, I'm missing a mic there.
Perfect.
Hi. So I was just wondering about, in terms of the options that you're providing, somebody makes a decision on those basis. From your experience of your current clients, what are they using to base their decisions on? And is there anything that any sort of decision metrics that are thrown out of there, any considerations that have surprised you that you wouldn't have expected from starting with at all?
Good question. I mean, at the stage that we're working at, cost and value and return is obviously quite a big driver. But we're starting to see more and more that, there are other factors like what kind of space am I creating? The environmental considerations are starting to be part of the story. And that's something that we really wanted to achieve with SiteSolve, is if we can bring that information really early on, then let's drive that from the very beginning. I wouldn't say any of them necessarily surprise me, and I would say it changes from client to client and even between project and project, because the drivers are always different, and that's why we have the ability in-house to kind of tweak the algorithm and the optimization solver that we're using in order to tweak that so that it meets or at least tests various different strategies that the client is interested in.
So you mentioned the difference in project to project and client to client. Where do you see most of your interest in SiteSolve? Is it via the actual architect, or is it the developer? Where are you guys seeing it at this point?
It's a whole mix, actually. And that's, I think, something that surprised us a little bit. You have some architects who are obviously wanting to use it to help make their design process faster, test different options, help to use it to give evidence to their story that they're giving to clients. We have some developers who want to use it at that really early stage to maybe even just work out whether that site is worth them investing in an architect for. And so they want to use it to get that really quick idea, what is possible. But then we're also, speaking to sort of local authorities or public bodies that, maybe do a bit more of that portfolio bit like I showed with TfL, in order to, help them to prioritise. So yeah, a whole range, and who knows what might come next.